In last lecture, we have continued to work on the memory. This lecture will be no different. We'll be again talking about memory. This lecture will be again additional information lecture. So if you feel the memory is clear to you, you can skip to the next one. But in this lecture, I would like to show you an example of very interesting things, how you can store strings in the memory. Okay, so let's start and let's begin with a new function here. So we'll leave this function as an example for you. I'll create here a new test function to several copy simply everything. I'll paste it under. All right, and actually, maybe we can write in a code so I can push it to GitHub for you later. So I'll copy this function. I will paste it here. Okay, so we don't need to expect anything here. We'll be just calling it without any parameters, and we'll call it test2. It can be external, it can be pure, it can return uint data, though no big deal here. Assembly MS store will keep here our free memory pointer to be pointing at the 0x80 by default. We don't want to point it to 0x90. Okay, so we'll remove this line as well. Items we don't need. We'll just leave here this one assembly block. And in this assembly block, I would like to store the new value into the memory. Okay, so first I will remove this. I will create here a new variable which will hold the value of my free memory pointer. So I will create here a new variable, let free memory pointer, let's write here a semicolon equal sign, and let's write here mload. So we are loading whatever is at the 0x40, which should be my free memory pointer. So I should get here value 0x80. The free memory pointer should have now. Okay, when we have this value, we want to store the value. We want to store the string. Let's say we'll be storing the string hello, simply hello. So I'll write here mstore. So we'll be storing in the memory at the position of the free memory pointer. Okay, and we'll be storing here a string 0x some string. So now we need to figure it out what is the string of the hello, and also maybe you want to do it traditionally this MS store as we done here before. So we would like to provide here the initial value of the byte offset plus the length where we'll be storing. Okay, so not the length, but basically the initial address plus offset, right? So I will say here at let's initial value of free memory pointer. So free memory pointer plus offset of 0 bytes, 0x00. Okay, of course I can leave here when we are storing this initial value. We can just leave here this, but we'll go more traditionally. So when we want to allocate some new value on the second spot, we'll write here 0x20. All right. So this will provide the new value 32 bytes further into the memory, but we are providing it exactly at the memory pointer. So 0x00. Now we need to figure it out what's a word hello in binary format. Okay, so first of all, we need to agree on the type of encoding we will go with. We will go with the ASCII encoding. Okay, so basically with the ASCII encoding, you can encode binary data into some string value. Okay, you have also UTF encoding that encodes more values, but the ASCII will be enough for us. So let's open here a new tab and let's search here ASCII to binary. Okay, we'll take a look at this also in bigger detail very shortly after this. So let's write here input of your string hello. Let's write here, or actually let's convert it first like this, and the output delimiter string, and you can see here that's the hello world in a binary format. So you can see here this is encoding for H, E, L, L, and the O, and each letter is encoded by with 8 bytes. Okay, so you can see here. Not 8 bytes, but 8 bits, 1 byte. Okay, so 8 bits, and is 1 byte in total. Okay, so now let's provide it as a one value, so without any spaces. I will click here delimiter, and I will say here none, and I will convert it again. So this will just join it together. That's the value of the binary. Now I would like to transform it into hexadecimal. So we'll go to our previous table, and we'll transform from a binary into hexadecimal. Let's provide your value, convert, and you can see here your hex number. That's the value in the hex number for a hello string. Okay, so I'll copy this value. We'll get back, and I will simply store it there. So 0x and the hexadecimal value Okay, now it's as a position of 0x80. And now, when we want to return a value from an assembly, I didn't actually showed it already in the previous lecture, so we need to specify here only the name of the variable we'll be returning, so in this case data, and we'll get here data, and we'll assign there, we'll assign here mload at the free memory pointer. Okay, we can do it as well as the same as before, at the free memory pointer at the offset 0. This should load me the value in a decimal format, because I'm saying here return me uint. Okay, so this will basically return me the value of decimal number, so 4483 and so on. Okay, so now we can save it. Actually, we need to copy it into Remix. So let's copy this entire function. Let's get back to Remix. Let's get this function here. So we have two test functions. So I'll remove this one. I will paste it. Perfect. And let's save it. Let's try it out. Okay, so we need to recompile. So click here, compile. Let's go to deploy tab. Okay, deploy. Let's remove this, deploy the new contract, and let's call function. So clear it out. I will call the function test2. As soon as the function is called, I will see the output. So I will click here so I will open more additional information about the function, and I can see here uint 256, and the data is a decimal number for a hello string. So that's the value, this value here. Okay, so I'm definitely getting my value from the memory. Perfect. Okay, and also one interesting thing here, I will unzoom it, I will debug it. So let's click here on the debug up here. Let's write a breakpoint, let's say here on the data, 28, and let's jump into this breakpoint. So let's click here, jump to the next breakpoint. Okay, and let's notice here your memory. Okay, at a 0x80 with the offset of 32 bytes as we specified here, we are saving the string hello. You can see here it's a hexadecimal format is here, and now you can see here purpose of this question mark. So this is a decoded format for this hexadecimal format. In a decoded format is a hello string. So that's what you are basically getting back. Amazing. Okay, also an interesting thing, if you don't want to get here data in uint as a number, you can specify here, for example, you will specify here bytes, 32 bytes length, okay, and data, and you will get here now hexadecimal format. So when you save it, again, we need to recompile and all of this stuff. So compile, we'll redeploy, so we'll remove previous contract, deploy, clear it out, and let's call here function test2, open it, and you will see here, you are getting here this hexadecimal format here. So now 68, 65, 6C, and that's a hexadecimal format for your data. Amazing. So that's what you are getting. If you are interested into how your string is encoded, just simply look here, ASCII table. Okay, let's see here. Okay, and let's see. So here is every character here has its binary format, so you can encode it. So for example, if you are looking for a letter H, so let me find the letter H. It is a capitalized H, and there is a difference between capitalized and small lowercase h. So we are encoding lowercase h, and you can see the value of the lowercase a is 104 in a decimal format, and in hexadecimal is 68. Okay, so you can see here 68 in hexadecimal. So you can notice here your string is starting with a 68. Okay, got a point? 68. The second value here is a 65. So let's see what is a 65. 65 is E. So hello. Now under 65 we should have, right? So under 65. So 65. Oh, 6C. That will be for L. Two 6Cs. So 6C. Let's search here for 6C. Here it is. L. Encoded L. Okay, so that's encoded L, and O for a last word is a 6F. So O, 6F, here it is 6F. And here is also have a binary format. So for example, it has a binary format, it's a decimal format of 101. Okay, so for example, when I will go here and my first hello, let's convert it into with the spaces so you can see the individual bits. So that should be for a H. That should be only H value. All right, this is H value, so I'll copy just the H value. I'll go here, binary to decimal, paste it here, convert, and it's 104. Okay, so 104 is H. That's what we are looking for. Okay, and 104 in a binary is this value here. This is 104. All right, guys. So yeah, that's gonna be it from this lecture. I wanted to show you this. In the next lecture, we'll continue again with the memory. I promise it will be last lecture of the series. It will be much shorter, but I would like to show you also one interesting thing. Any questions? Ask them in Q&A, and see you in the next one. Cheers.